Good morning, one and all. Welcome back to the video lecture series for linear integrated circuits and its applications. This is Professor Dr. P SREENIVASULU. Today, we are going to discuss about the non-inverting amplifier. Now, already in the previous class, we have seen inverting amplifier. Now, inverting amplifier, we have noticed that the input terminal is connected to inverting terminal and non-inverting terminal is connected to ground. If we observe at the output is inverting of input voltage. So there is a 180 degrees phase shift between input and output. And again, there is getting gain, depends upon the designer. Now, if you see in the non-inverting amplifier, the basic difference, previously we have applied input for inverting terminal. Now, we are going to apply for non-inverting terminal. We are going to apply for non-inverting terminal. And the inverting terminal is connected to ground through a resistor. And as usual, output is connected. Now, again, if you analyze the circuit, the main principle, virtual ground concept. So, what is the virtual ground concept? The difference between non-inverting terminal and inverting terminal must be zero. The difference between non-inverting and inverting. So, here at the non-inverting terminal, the voltage is VI. At the inverting terminal, the voltage is same. Then only it is going to be zero. So, it is the meaning of virtual ground concept. So, whatever the voltage at the non-inverting terminal, the same voltage you are going to be assumed at node A, then VI difference is zero. It is the concept of virtual ground concept. Now, either of the input terminals draws no current. Either of the input terminals draws no current. Now, if you apply nodal analysis at node A, or if you see, again, it is going to be solved in two methods. One method is, if you observe the current, whatever the current we are showing there, direction, it is showing from output to node A. And the same current is also flowing through R1 because the inverting terminal is not drawing any current. Now, what is I1? V0 minus VI divided by observe here. You see, V0 minus here is given directly, but we follow the method notation to avoid the confusion. If you want to calculate this current, V0 minus this voltage, VI by what is this resistor? RF is equal to what is this voltage here? I want to calculate this current. What is this current? VI minus 0 by R1. Now, these two currents are same because this current is entering. If you assume another current, this current is leaving, there is no any current. These two currents are same. So, based on that, we are going to be calculated. Otherwise, simply, if you apply nodal analysis here, what is the voltage? VI minus 0 by R1, VI minus V0 by RF is equal to 0. So, by applying this one, we will get that gain, output voltage gain, V0 by VI is equal to 1 plus RF by R1. So, whenever it is a 1 plus RF by R1, if you compare this gain with inverting amplifier, what is the inverting amplifier gain? V0 is equal to, V0 by VI is equal to minus RF by R1. The gain of non-inverting amplifier is greater than inverting amplifier. It is one point. Another thing, there is no any phase shift between input and output here. There is no any phase shift between input and output. So it is called a non-inverting amplifier. So based on the selection of RF and R1, we are going to get whatever the gain we require. Next one is voltage follower. So in the name itself, voltage follower means the output voltage follows the input voltage. In the name itself, voltage follower means the output voltage follows the input voltage. Now, whatever in the non-inverting amplifier circuit, we are going to do some modifications here. What are the modifications? First one is in the RF is 0. So RF is equal to 0 means it is short circuited. Next, in the RI input resistance, it is going to be infinity. Infinity means it is a open circuit. So these are the two modifications we have done in non-inverting amplifier. You need to make a voltage follower. You observe the circuit diagram of non-inverting amplifier and you observe the circuit diagram of voltage follower. You cleanly observe what is the RF here. RF, it is equal to 0. R1 is equal to infinity. So whenever the resistor is infinity, the current is 0, then it is open circuited. So whenever the resistance is short circuited, the current is there, but voltage is 0. Now, the same formula, or simply, we have a concept, virtual ground concept. The difference between non-inverting terminal and inverting terminal must be 0. So already in the non-inverting terminal, the voltage is VI. So the same voltage is appeared at VI, inverting terminal. That is going to be connected to V0. So V0 is equal to VI. Now, it is the gain is 1 here. So usually it is going to be used for buffer or impedance matching. It is the concept of voltage follower. You see the simple problem. I design a amplifier with a gain of +5 using one op amp with a gain of +5. So with a gain of +5 means definitely you need to consider a non-inverting amplifier because there is a positive gain. So we know according to non-inverting amplifier, the closed loop voltage gain is equal to 1 plus RF by R1. He has given the gain. What is the gain? 5. So 5 is equal to 1 plus RF by R1. You need to assume R1, suppose it is R1 is equal to 10 kilo ohm. R1 is equal to 10 kilo ohm. So whenever R1 is equal to 10 kilo ohm, so 5 minus 1, 4, RF is equal to 40 kilo ohm. So it is the simple design of a non-inverting amplifier. Like that, for any value, we can design a circuit diagram. Better you see this problem here. See the circuit. The circuit shown in figure and the above figure. R1 is equal to 5 kilo ohm, RF is equal to 2 kilo ohm, and Vi is equal to 1 volt. A load resistor of 5 kilo ohm is connected to at the output as shown figure. Calculate V0, closed loop voltage gain, load current, the output current, indicating proper direction of flow. Now, first of all, you write the given data. What is the given data here? R1 is 5 kilo ohm, RF is equal to 20 kilo ohm. So, based on this R1 and RF, Vi is also given 1 volt. We can calculate the voltage gain, output voltage, not gain, output voltage. So, if you see voltage gain, closed loop voltage gain, V0 by Vi is equal to 1 plus RF by R1. Now, V0 is equal to 1 plus RF by R1 into Vi. 1 plus RF, what is RF? 20 kilo ohm by R1, 5 kilo ohm. 5 for the 20, 1 plus 4, 5. So, into 1 volt, so 5 volts. It is the output voltage. Next, closed loop voltage, anyway, it is the already output voltage is 5, input voltage is 1. So, V0 by Vi is equal to 1. Otherwise, from 1 plus Rf by R1 also we can calculate. Next, IL. IL is load current. It is equal to V0 by RL. So, V0 is equal to 5 volts. RL is equal to, I think he has given the data. RL is equal to 5 kilo ohm. So, it is a 1 milliampere. Now, what is the I1? What is the I1? I1 is equal to, if you observe I1 is equal to V0 minus V1 by RF. V0 means output voltage, V1 means input voltage by RF. If you calculate, you will get it is a 0.2 milliamperes. So, today I am going to stop this. Tomorrow we will continue in the next class, next topic, differential amplifier.